So I just revise that first and then we come on our topic, that is increasing decreasing functions. So first Lmvt, and which I told you, Lagrange mean value theorem, also called as mean value theorem. And in this case, I told you in this theorem, let fx be a real valued function. Defined on closed interval AB such that first condition was fx is continuous on closed interval AB second is fx is differentiable on open interval AB. Only these are the two conditions. In Rolle's theorem, we had third condition was also there, fa is equal to fb. But here we don't have fa is equal to fb. We'll say it is continuous and it is differentiable. Then there exists C belongs to AB, open interval AB, such that f dash C comes out to be FB minus FA by B minus, such that f dash C will be FB minus FA by B minus A. If this condition holds, first I told you Lmvt is what? This says that if there is any function which is real valued, function is real valued, defined on closed interval AB, then that function should be continuous in closed interval AB, differentiable on open interval AB, then there exists a point C belongs to open interval AB such that f dash C will be equal to FB minus FA by B minus A. Rolle's theorem and this, only the difference is FA is not equal to FB. In this case, if you put FA is equal to FB, automatically this will convert 0. So that means this will convert into a Rolle's theorem if you put FA is equal to FB is the condition. So it is a more general equation, that's why simply also called as mean value theorem. It includes your Rolle's theorem also. Now what it want to show, that's just check that also. In this case, the missing case is FA is not equal to FB or FB condition is missing. This is x is equal to A, this is x is equal to B. Let this is FA. And another one, let it be FB here. So this point will be having coordinate A and FA. And this point I am saying B and FB. This is FB here. They are not equal. FA is not equal to FB in this case. But whatever function given here, that will be continuous in this interval. This function is completely continuous. Second way, it is differentiable also. Continuous means without break you have to plot the curve. And second one, it should not have any corner point. So that means the curve goes like this. One is here. Or can be this also. 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 Any type of curve it can have. But keep in mind the curve should be continuous and differentiable. And when you have a continuous and differentiable function, then what it says that there will be a point C. There will be a point C on each curve, which will be between A and B, such that on that point, let it be C. On that point, if you draw tangent, that will have slope same as this point, chord slope, PQ. This is the chord joining initial and final point. What is the slope of this line? Y2 minus Y1, that is FB minus FA by B minus A. So we have every curve one point where if you draw tangent, that tangent will come parallel to the chord joining PQ. तो जो ये PQ है आपका, इसका जो स्लोप है वही स्लोप आपको यहाँ मिल जाएगा, वही स्लोप आपको यहाँ मिलेगा, वही स्लोप यहाँ मिलेगा, वही स्लोप यहाँ मिलेगा. Same way you will have the slope here also. You have the slope here also, here also, here also. So everywhere what you will find the slope come out to be parallel to chord this time, joining initial and final point. And by the way, if FA is equal to FB, then automatically this point will shift here and this tangent or this chord will become parallel to x-axis and this come out to be 0. So what is the Lmvt says? It says that if the curve is continuous, if curve is differentiable, there will be a point C on the curve where if you draw tangent, that tangent will come parallel to the chord joining PQ. That you should keep in mind. So this way you have Rolle's theorem, you have Lagrange mean value theorem. Now coming on our topic, which is in our syllabus, that is increasing decreasing functions. Increasing decreasing functions. Next topic we are taking increasing decreasing functions. Or in that first thing which we are going to discuss, that is strictly increasing function. Strictly increasing function, what it is, we should know it. So write down the definition, please. A function fx is said to be strictly increasing on open interval AB if what condition comes, just note here, if x1 is less than x2 implies fx1 is less than fx2 for all x1 and x2 belongs to AB. A function fx is said to be strictly increasing on open interval AB if x1 is less than x2 implies fx1 is coming less than fx2 for all x1, x2 belongs to AB, right? AB is the interval. Now, what is the meaning of it that you should make clear? This is the function we have. And let the shape of the curve is like this. From this diagram, it is itself clear that function is increasing. And now when you think about the mathematical way, what changes here or what you want to explain here, it says that if you take any point x1 here, or you take another point x2 here. So 2 points we have taken, one is x1, another is x2. Just check what is fx1 here. And here we have fx2. What you are finding here, as you increase x, at the same time your fx is increasing. x1, x2. What I told, x2 is bigger than x1. This x2 is coming bigger than x1, and at the same time, what I get here, fx2 also coming greater than fx. X1 when you are increasing, or x you are increasing, at the same time your fx should increase. Means by increasing one, you will get the second also increases, or you put the value of x more, your function is going to be more. So here what you will find, if x2 is bigger than x1, at the same time fx2 is also coming greater than fx1. And if this condition holds, we will say function is strictly increasing. Strictly increasing means by increase in x, the function should increase, or fx value should increase. So if it is increasing, at the same time it should also increase. By the way, the curve comes like this. In this curve, what you will find here, in this curve you will find that in this interval it is increasing. Here it will become constant. Here it is increasing. So here if you take x1 and x2, what you will find, fx is also going to increase. Here if you take x1 and x2, what you will find, if x is increasing, function is increasing. But here if you take any 2 points, x1 and x2, then fx remain what? Constant. So in this case, what you will say, it is not strictly increasing. There are some places where it is completely increasing, but some places it becomes constant, but not going down, not decreasing. So what you should say, if that condition comes, what change will be there? Then we'll say a function fx is said to be not strictly now, is increasing on AB if x1 less than x2 implies fx1 is coming less than fx2. Fx1 is coming less than fx2 for all x1, x2 belongs to AB. Then we will say it is not strictly, it will be increasing function. So it is an increasing function. Increasing function means most of the time it increases, but some time or few interval or small interval it can be a constant. Then we will say it will be increasing function. So whenever increasing, it will come equal. Not this x we are going to increase, but what you find at certain stage fx2 is greater than fx1, but at some places fx2 and fx1 will become equal. So we will say it will be increasing function. But we are going to study only the strictly increasing function. So whenever I say increasing function means strictly increasing. Second one, decreasing function. Strictly decreasing function. Then we will say a function fx is said to be strictly decreasing function. A function fx is said to be strictly decreasing on AB if x1 less than x2 implies fx1 is coming greater than fx2. For all x1, x2 belongs to AB. That means in this case the curve will come like this. This is point x1 we have, this one is the point x2 we have. x2 is bigger than x1 means x we are increasing, but what about your fx? Just check here. This is your fx1 and this is your fx2. So I should say fx is going down. X you are increasing, but the function is decreasing. Here I told x2 is bigger than x1, but fx1 is coming greater than fx2. That means this will reverse. By increasing x, fx decreases. If that situation comes, we will say function is strictly decreasing. So we will say it will be a strictly decreasing function. By the way, the curve comes like this. Then what you will find, this is decreasing, this is strictly decreasing, but here in some interval it is becoming constant. Then this is coming equal also. Then we will say the function is said to be decreasing on AB if this condition holds here. Then we will say only a decreasing function. It will not be a strictly decreasing function. Again, I told you that whenever I say in this chapter, whenever I say decreasing or increasing, we are concerned about strictly increasing and decreasing function. So one thing you should keep in mind, what is strictly increasing function? That function in which as you increase x, fx should increase. Second one, decreasing function says when you increase x, fx should decrease. So if by increasing x, fx increases, it's increasing. If by increasing x, fx decreases, we call that as decreasing function. That you should keep.